Hey y'all, so today we're going to be looking at Dalton's atomic theory and some of the modern atomic laws that stemmed from that. So let's go ahead and get started. So first off, Dalton's atomic theory can be kind of stemmed from a bunch of different smaller aspects. I mean, he made this statement back in the 1800s. He was a school teacher in England, didn't have a lot of really high-tech devices to base this off of, but he did do a lot of really solid science to kind of help support the idea that matter was composed of atoms. So basically what I'm trying to say is this, is that when you read in a textbook, when you go online and look at some videos about this or anything like that, you're going to get a list that could be anywhere from 3 to 5 list items long. With that being said, these are the 4 that I think are important. So statement number 1, matter is composed of indivisible particles called atoms. Indivisible means that you cannot cut or destroy them. Basically, he thought that atoms were tiny spheres that connected to other tiny spheres. Atoms of the same element are identical, meaning that if you have carbon, that's going to look exactly the same as the next carbon atom. If you have hydrogen, that's going to look exactly the same as the next hydrogen atom. Atoms of different elements combined to form compounds, meaning if I have hydrogen and oxygen, I can combine them in a certain ratio to form water. If I have carbon and oxygen, I can combine them in a certain ratio to make carbon dioxide. And last but not least, the last statement he made is this: in a chemical reaction, atoms separate, rearrange, and combine, but never are created or destroyed. Essentially, this is the law of conservation of mass, which we'll get to in a second. Now, as I said, these statements were created and made in the early 1800s, over 200 years ago. So while a lot of these are still somewhat true, we know that there's a couple things about them that are currently false, if you will. So what's wrong with this? Atoms totally are subdividable, meaning that atoms are made up of smaller, what we call subatomic particles. Those subatomic particles are the protons, neutrons, and electrons. Atoms of the same element can be different. So what I mean by this is that if I have a carbon atom, this can technically be different than another carbon atom. For example, carbon-12 and carbon-13 are different forms of the same atom. We call these isotopes, and the way they're different is based on the number of neutrons they have. Now, as far as this goes, they have similar chemical reactivity. They just have different masses, and they may have somewhat different nuclear properties, but nuclear chemistry is a whole other field, whole other worldview. As far as the chemical reactivity of the carbon atoms goes, they're pretty much the same. So with that being said, we're going to go ahead and transition to 3 modern laws that we follow pretty well in our AP chemistry world. The first one is the law of conservation of mass. The law of conservation of mass basically says matter or atoms cannot be created or destroyed. Basically, in any process, whether it's chemical or physical, the mass of the reactants must equal the mass of the products. Essentially, all that happens is that atoms will separate. If they are bonded on the reactant side, they'll separate, they'll rearrange, and then they will reform or combine in different ways. And essentially, that's what the law of conservation of mass says. Now, as far as the law of definite proportions goes, it is a little bit more hefty of a statement. It says this: in a given compound, the type and amount of element is constant. The way I like to look at it is this. If I were to have water, I want you all to think about the formula, the chemical formula of water right now. You're probably thinking, all right, it's H2O. The formula of water doesn't change. Every molecule of water on planet Earth or off planet Earth has the formula H2O. And that's what the law of definite proportions says. It says that for a specific compound, if it has certain elements in a certain way, it will make a specific compound. And you cannot change the ratio and still have the same compound. Water is always water, regardless of if it comes from the sprinkler outside, from the rain clouds up above, from my sink over in the back. Now, this last law that we're going to go over is definitely a hefty one. And I'll give you what is the written law, but I'll also give you a good way to think about it. So, the law of multiple proportions says this: if two different elements combine to make two compounds in different ratios, the masses of the second element that combine with a given mass of the first element are in small whole number ratios. Now, as far as this goes, once again, it's not actually too terrible. Basically, it's saying this: just because you have two elements doesn't mean they need to combine the same way every single time. A good example of this would be the way that carbon and oxygen can either form carbon dioxide or carbon monoxide. The formulas for those are CO2 and CO, respectively. Essentially, in carbon dioxide, there's always going to be twice as many oxygens as there are in carbon monoxide, CO. And based on the math and proportionalities of this, you will always have a small whole number ratio between their masses. And that's what the law of multiple proportions says. Now, while these laws are incredibly important and good for us to know, we will apply these mathematically a little bit later on down the road. So I just wanted to make sure you had those on the back of your mind as we get into the school year this year. Thanks so much. Have a great day.